project team, and the project is based around open source software-based networking infrastructure. I'm Andrew Larson. I was the team lead and the firewall engineer.
I'm Matisse Solomon. I was the land engineer for this project.
I'm Alex Hansen. I was the land engineer for the project.
And I'm Tanner Blomster, and I was the Linux administrator.
We'd like to take a quick second to thank our target sponsors for being here, taking the time out of their day to meet with us every Friday. You know, everybody has a busy schedule. Craig, Jeff, Josh, Chaz, Lucas, and Justin. Just thanks for letting us be a part of this project. We had a lot of fun doing it with you guys.
So on the agenda today, we're going to go over the problem statement of work. We're also going to talk about why open source is relevant to industries today. We're going to show you guys our design, our network, and then we're individually going to talk a little bit what we contributed to this project. We're going to do a demo, summarize it, talk about lessons learned, and then we're going to open up for questions and answers.
All right, so just to kick things off from a non-technical standpoint, kind of what Target kind of expected from us, and it's write the statement of work. One of the things that stuck out to us is they pretty much told us to fail right from the get-go, and then fail again, and again, and again, and then finally succeed. So, and obviously that's not a bad thing. What they meant was that, you know, they gave us full reign to pretty much take this project and do whatever we wanted to do with it. So obviously, you know, along the way we're going to run into some bumps in the road and have some headaches and shed a lot of tears. But they were along the rest of the whole way, giving us support, and kind of pointing us in the right direction when we ran into some issues. So thanks again for that. But then on the technical side, what we're supposed to do is we're supposed to set this fully functional network using strictly only open source software. Now, for those who may not be familiar with open source software, it's software that's essentially it's created by community people, given out to the world so that anyone can take it and kind of tweak it and make it to fit their own needs. So the softwares you see up on the screen, they're not specifically designed to work together. But we took them and we configured them so that they were all able to play nicely together. And then while we're also designing it, we had to keep an infrastructure as code mindset as well. And Tanner's going to go into more detail on his part of the presentation, but essentially that's like having a centralized location where you can store all the configurations and settings of these devices. And so we can view them, make changes, and kind of push them out as we see fit. So in the end goal, yeah, we had to have this open source network and have infrastructure as code set up, and also cry a lot. So why open source then? Well, some of the big benefits that we kind of came up with while we're doing this project is that overall you can save a lot more money going open source. And this is generally speaking, but usually you don't have to spend a lot of money on licensing, hardware, or you don't even have to pay for vendor support typically, unless you really want to. And along with vendor support, if you have a device on your network that's supported specifically for a vendor and you see that there's an issue with it, typically you're kind of locked in place. You kind of got to wait for that vendor to come up with a solution for you. With open source, if you know what the problem is and you know how to fix it, go ahead. You can go out there and fix it yourself, or even if you don't know the answer, there's a huge community out there that can tell you how to fix it possibly. So, and then one of the other cool things that we kind of learned, and what we understand that Target does from a business perspective, is they take the money that they save from all those factors and they reinvest it back in their engineers. And that gives them people that are passionate about the technology and they know the technology like the back of their hand. So ultimately, you're going to come up with more creative solutions. And some of the bigger names you can see up on the screen there, Google, IBM, Ticketmaster, Amazon, and obviously Target, is they have a lot of open source technologies implemented in their networks. And so that's kind of why open source. Andrew's going to talk about why infrastructure is code.
Yeah, so why do we want to use infrastructure as code? Well, infrastructure as code is a protocol called GET, and it allows us to have a universal space to edit all of our configurations, such as configurations for switches, firewalls, routers. All of this can be stored in a centralized location. We can have multiple engineers collaborating it, even on the same time, editing the same configuration. So we can get input from multiple people, and we can make sure that all these changes are stored in a single location. In addition to this, once we make those changes and they get approved, it can go through a hierarchy of approval process. So we could have a manager and even a manager's manager take a look at those. You can see all of the changes that are made highlighted in red, and if they're approved, they get turned to green. So we can go back and see, these are the changes that all of our engineers made, and the managers can take it, look at it from a high-level perspective and see these are good changes, these will benefit us, and these are why. And then if for some reason those changes don't work and we push it out to one store or a few stores, and all of a sudden they start breaking, we can revert back to our old working configurations because this is a source code repository, so we're gonna have multiple configurations going, new ones, old ones, and even test ones going at the same time. At the bottom of the screen, we have just a few of the biggest companies, I think you'll all recognize them, using infrastructure as code in addition to Target. It just makes sense, and you can see that the industry really shifting towards this, especially with multiple stores, multiple locations. This makes it a lot easier to configure devices and store all the configurations in one pane of glass. So after we got our statement of work, we kind of all put our heads together, and this is the topology we came up with. So we segmented our network into 4 different sections, as you can see color-coded. We have our web server, our clients, our LAN, which is just our servers, and then we have the internet coming in the red. So we're using pfSense to have all the traffic filtered through. That's our firewall, and then we're using OSPF, a dynamic routing protocol, to advertise to all the other network segments that we have, how to get to the internet, and how to get to other segments on the network. And as far as the web server and the clients go, we're allowing ports 443 and 80, so that clients can get to internal web pages, such as like if your company had any, like a company directory or something like that. And then the clients were also allowing port 3389, which is better known as remote desktop. So we could have like technicians come in and take a look at, you know, end users' computers, maybe remote desktop in and troubleshoot some problems. Next, I'm going to pass it over to Matthias to talk more about the switch.
Yeah, so during this semester, I've been working on the edge core switch, and when Target handled this edge core switch, I've never even heard about edge core before, so it was quite a challenge. So like, imagine you get a computer handled to you, and you don't know if it's a Windows, it's a MacBook. So first half, it was lots of research to do, but what this edge core switch does to you, it gives you the freedom to install whatever operating system that's out there that would fit your needs. So the first half, we did a lot of research just to find the right solution with the operating system. And there are licensed and there are free operating system out there. And we wanted to try the free version first. So we got like FBOSS, which is Facebook, we got Sonic, which is Microsoft. And then for the longest time, we tried ONL, which is Open Network Linux. And as Alex mentioned before, we failed, and it was so tough for us, but we ended up choosing PICA-8, which was a license cost, so we want to thank Target for getting that to us. We hope it wasn't too big of a dent in your budget. But when we used that, it took us probably a week to set everything up to connect to our network with OSPF and LAN segments. And we chose it because it was similar to Cisco command line, which we use here at Stout, so it was a pretty good fit for us.
Yeah, so to jump into the firewall, we use pfSense. It connects directly to the switch, and it kind of is the backbone for our security in our network. What is pfSense? It's an open source free router firewall that can be really customized to anyone's specific needs. It has a super awesome package manager that you can download tons of packages, and the community inputs in all the time. We saw at least 3 updates while we were just working on this project to new packages, new versions of pfSense that we could have upgraded to. So you can see like we're getting a ton of community input on this particular firewall. So what does pfSense do for us? Well, it protects all of our networks from things like viruses or HackerMan. pfSense just really is the backbone for our security, and that's why we went with it.
So yeah, again, I worked on kind of the WAN part of the project, and for that we decided to go with zero tier. So just kind of in a nutshell, what it allows us to do is just connect, sites together. So if you have a branch in Chicago, you'll be able to connect to a branch in Milwaukee just fine. You'll be able to talk to each other as if they're one network. And then it also provides remote connectivity to people that aren't on site. So like a salesperson, they'd be able to hop on, like if they're in Taiwan, they'd be able to hop on to the corporate network just as if they're in their own office there. And that was the kind of big push for me to get this part of the project done. Because when we first started this project, whenever we wanted to work on it, we had to go into the Capstone room. And then on top of that, there was only 2 connections available for the 4 of us to share. So that meant the 2 of us that aren't on the network, you had to like tap them on the shoulder, like, hey, can you make this change for us? Or we just steal their cable if they weren't looking. Yeah, after we got zero tier set up, things got a lot easier because we were all able to connect to the network at the exact same time, which made it a lot easier for us to work together. And then, we can work from the comfort of our own homes, or even while we're on spring break, because what else do you want to do on spring break? besides working on the Capstone project. Yeah, so I guess why we chose zero tier. I never worked with any open source WAN softwares before, but these guys have, and then everyone online, they all say that it's super easy to use and set up, so I figured, that's an awesome place to start. And then, when you kind of think of easy and simple things, it's kind of like a one-trick pony. You kind of expect it to be really good at just one thing. But with zero tier, as playing with it, it kind of has a lot of advanced features, even though it's so simple to use and set up. So that's just kind of zero tier in a nutshell, what it allowed us to do. And then I'm going to pass it over to Tanner to talk about kind of the backbone of our project.
Okay, so if you want to get started with infrastructure as a code, really the best place to start is to start using Git to store and manage all your device configurations. What Git really allows you to do is store all your device configurations in a single pane of glass, a single location, not your device configs on some shared drive in a text document where you copy and paste into, all your new routers. Can't say how many times they've used up their own equipment doing that. And Target chose GitHub, which is the most popular hosted Git service, which, no surprise. But we really wanted to go with a kind of a self-hosted thing to do whatever we want, not rely on, again, a third-party, hosting solution. So we chose Git. And really one of the primary reasons we chose Git was because it's super easy to set up and it's very lightweight. Right on their website, they say it can run on a Raspberry Pi even, so it's a pretty nice software. And we have a graphic here that shows, kind of the workflow. So multiple engineers can push their changes to a Git server. And then really now so when we chose Git, now we're at the project, we're like, well, now we needed to choose how do we get these configs to our devices. So just kind of goes from that server to our network, the firewalls and the switches. And what we chose was Ansible. Ansible is a really popular automation and orchestration platform. On our visit to Target, we also saw that Target also chose Ansible for their future network. So this is kind of the workflow of how the automation would work. A new change is approved to a file in Git, and then our Ansible server automatically pulls those changes from that repository. And then on a schedule or on a chosen time or even manually, you can send those changes up to those devices, and then the new changes appear. And Matthias is going to go over more of a physical workflow.
Yeah, thank you, Tanner. So yeah, just to get a better visualization of how it works. So the engineers who works on the firewall switches, let's say they want to make new changes at a remote store. So after going through the hierarchies and changes and approves, they'll commit, and then Ansible will recognize that change and automatically send out over the firewall, over the internet with encrypted data using zero tier, and it will push out the configurations to the remote firewall, to the remote switch. And we're gonna go to our demonstration now and show how this will work. So right now, I'm in the switch, and PicOS has like 2 layers. So it has a Linux shell, and it has a layer 2, a layer 3. So when you log into the switch, you get to the Linux shell right away, so we can use just a simple command that used in the Linux. So I'm going to show you the config files. So right here, as you can see, we got a bunch of pica.conf. So every time you make a change in your configuration file, it'll store so you can easily revert back from that change. And if we just do an eccat command, this is how the configuration file looks in the Linux shell. So you can see we got our VLANs right here. But then also, as I said, you got a layer 2 and a layer 3 mode, which is right now. And this is the mode that's more similar to Cisco. So if you just do a show, you'll see your configuration file. And for you guys that know Cisco, it's a show running config. So it saves you some time, so you don't have to type all that. But now I'm going to show the old-fashioned way of how to configure a switch. So we see the VLANs that we have right there. And let's say Target wants to add a VLAN to their switch. all they have to do is set VLANs, VLAN ID, and let's just do 150 right there. But you also have to commit the changes, because if you exit the prompt right now, the changes will not appear, and we'll have a commit, okay, save done. And we can also, and I'll show you right here. As you can see, VLAN 150 just appeared in the configuration file, but that's the old way of doing it. So now I'm gonna hand it over to Tanner, and he's gonna show you our way.
Right, so as Matthias was saying, this is kind of the old-fashioned way to do it. But, you know, if you're like an organization like Target who has, you know, over 1,800 stores, no one's gonna wanna log in and type those commands in on every switch they have, you know. So what we can do is use an infrastructure as a code mindset and Ansible to really automate this process. So I'm on our Git server here, and I'm looking at a code repository for Ansible automation. And I'll pull up our switch configuration, which looks pretty similar to what Matthias just showed you. It's kind of got all the same configs and everything in there. And then you can edit this here, or you can sync this repository to your local machine and use any text editor you want to, and then push it back up. So say, you know, I want to make some test VLANs here. So as you can see, we already have some test VLANs, but I can actually delete all these if I want. And I can just make another VLAN. We'll use VLAN 300, for example. And then we can close that. Then we can commit those. So now our config is stored in Git, but the device doesn't have this configuration yet. So I'll go over using Ansible to push that configuration out. And as we said, this can be a schedule, this can be manually like we're going to do now, or you know, whatever you want to do. So I'll leave the switch screen up so you can see what's going to happen on it. Right now, our Ansible server is going to pull down those changes and then start pushing them out.
So what's cool about this too is this is just one device. So like Tanner mentioned earlier, if you have 1,800 stores to deploy switches to, you can hit all those devices at once, or what we've learned, kind of what they do at Target too, is, you know, you can stagger it. So you can deploy to one store first, see if it works. If it works, awesome, hit the next store, or hit the next 10 stores. If they all work, then push out to the next 100. If you run into any issues along the way, then all you got to do is just put it back, and everything's back the way it was too. So.
Right, and that comes with the power of Git. You know, Git repositories can have branches, so you can have dev branches and alpha branches and beta branches. You know, whatever you want to do. Although you can see here that those changes just went over. So you can see the delta changes is my VLAN I just added, and then I also deleted the 3 VLANs that were already on this switch. So what's kind of nice about this is you can enforce configurations. So you know. So a technician comes to, you know, the store and manually goes into the command line and makes a change. You know, now that store or that device is different from all your others. And, you know, using some sort of automation tool like this, you can change it back to your approved official configurations. Now I will pass it back to somebody. Oh, sorry. We have one more demo. The firewall. We'll show you the rules here. So you can see the remote desktop that Andrew was talking about is allowed. So for example, we have a client PC, which is just a Windows 10 desktop that we can log into on our LAN. You know, do whatever we need to do, support the end user, whatever they need to do. Let's say, you know, we got a different remote support thing. Say we're going to use TeamViewer now, or we're going to use BombGuard or something like that instead of RDP. So now we want to block that, but we don't want to log into all of our firewalls and block all that rule. So we can go into here into our automation repo. And we can edit this config just like we edited the switch configuration. So we're going to find the RDP role here. And this type is pass right now, so I'm going to change it to block. Just wait on a minute. So now I'm just going to send these changes again. It's just going to run through.
Which again, this could be done all automated. You don't have to do, you know, like we're typing the commands here. We're just doing it purely for demonstration purpose.
And for the sake of time, we're not showing our other demos, but we do have, you know, configuring our servers, configuring our Windows clients to install certain applications. Ansible really has a module for almost anything. Okay, so our changes were applied. So now if I refresh this page, see our RDP role here is set to block. Now we can just run that. And so now if I RDP to the client machine, and hit connect here, now it's not going to let me in. Just a couple seconds, here maybe a minute, go grab a couple. Next with their demos.
Yeah, so lessons learned. I guess one of the biggest things that I got out of this project is right in the statement of work, is that failures are okay. I mean, there's plenty of times during this project, especially one in particular where I worked for having like 3, almost 4 weeks, so an entire month, trying to figure out one thing to get 0 up and running. And then I finally found the answer on a Reddit post online. And after that, it took me like 15 minutes to fix the problem. So it was like getting a high five and a kick in the shin at the same time. So, but overall, you know, if it wasn't for that failure experience of learning why I didn't understand why it wasn't working, I wouldn't been able to probably get a better understanding for why it actually is working. So.
Yeah, and one of the biggest lessons I learned as being team lead is just trying to find time where we can all meet together, because we all had, you know, way different work schedules, we all work different jobs. One of us even lives in a different state, so I mean, to find time where all of us could meet and work on the project as a team was a big challenge. But you know, I learned a lot from trying to coordinate everything and trying to get everybody to come together.
Yeah, I think lesson learned for me personally, like, I don't think we can stress enough the failure part, because that, it was frustrating time to time. But then when we finally, at the beginning of the project, we kind of went our individual way, but then towards the end, we kind of came together, we got the puzzle pieces to fit, you know. So that, I think that was the biggest lesson learned, that, you know, hard work will pay off.
And my lessons learned was really the value of communication. So I kind of had an idea of what I wanted to do to make this automation thing a reality. And I guess I didn't really, I just kind of told the guys, like, don't worry, I got this. But I think I really should have took a step back and said, hey, like, this is my idea, and this is how it's going to work. And I think that would have made us all kind of realize how cool of a project this is.
So just to summarize, I mean, we had a really good time and a lot of fun working on this project. We even got to go to Target's, you know, headquarters and meet their teams and see what they're doing as far as open source and automation goes, and working in Git and code as infrastructure. And we got to present our ideas last Friday to their teams in a little bit longer version. So we were super happy to do that. We learned a ton about open source technologies, how to integrate, you know, different open source technologies to work together, and using Git and a code as infrastructure. We can all see that, you know, big corporations and even smaller ones are going to start really utilizing these technologies in the future. So it was really nice to start working on it right now and get a little background on it.
Yep, we want to thank everyone in here for listening. Thank you, Holly, for giving us this opportunity. Thank you, Target. It's been a pleasure working with you guys. And as you see, we missed our meeting for this Friday. We're here already. Now we would like to open up for questions.